Now, whenever it is compiled, means that if there is no any error, if there is no any error in the line, so it is in C language. C language is a compiler based program. So compiler based means what? The translator program converts this human like code, whatever you have written, the source code, will be converted into machine language. Means object code, machine language, 0 comma 1, binary numbers, every bits binary, all are equal. Means what, if there is no any error, if error is there, compiler, what does the compiler? Compiler, it checks all the lines of code at a time, and then if any error is there, it will indicate that. So once you fix that errors, now compiler converts this source code into object code. That is called compilation. Okay. Then after, means at the execution time, means run time, this object code means converted into machine language, means 0 comma 1, that is to be given to microprocessor. So now microprocessor read that instructions, read that bits, and finally gives this result. This means the code is executed, then you will get this result. Okay, this is called execution. After execution you will get the result. That is called runtime, otherwise execution. Understood that? So as per this our statement, what is that? Static data structures, they are at memory size will be allocated at the compilation time. So memory size, maximum size is, memory size is fixed. Okay, but dynamic data structures, they are what? They, at the time of runtime, at the time of memory is allocated at the runtime or execution time. So that memory size is flexible. Okay, flexible means memory size can be increased or decreased. So okay, get my point? So basically we can categorize the data structures into two types: primitive and non-primitive. Primitive, as I have briefed that, to store single values like integer, char, float, boolean, okay, all that. And then non-primitive means abstract data structures. They will be made with the help of primitive data structures. Okay, and non-primitive data structures, there are two types. One is the linear, non-linear. In linear data structures, the data will be stored in sequential manner, like arrays. In arrays, data will be stored one by one. One memory location will be connected to another memory location, and one element is connected to only next another element. That is called linear. Means data will be stored in sequential manner. So here examples are what? Your arrays, linked list, and queues, stacks and queues. So non-linear data structure, one element is connected to n number of elements, okay, known as non-linear. Here trees and graphs, they are arranged in random manner. So next is what? Static, I have briefed you. Dynamic, I have briefed you. Now what are the major operations we can do on data structure? Major operations, that is what? Searching of data, sorting of data, insertion, updation, deletion. As I told you that data structure is a way to structure or store the data in memory locations of computer. So it is called data, how to structure the data, how to organize the data, how to store the data in computer memory locations is called data structure. It is not a programming language like C, C++, Java. Okay. So data structure, we can store the data in any language, C, C++. Different data structure has different ways, different syntax to store the data in memory locations. Okay, so by data structures we can do the following operations. Searching means we can search an element in data structure. we can sort ascending and descending order, we can sort the data structure, elements of any data structure. Okay, if data is stored in array, so we can ascend the order and sort the order and descending order. Insertion, we can insert the new element in a data structure. If array is there, we can insert an element, otherwise we can delete any element, we can remove the element from the data structures. Okay, so and we can update, we can change, replace the element. So these are the operations we can do on the data structures. So data structures, as I told you that, yes, I hope that you simply understand that. Okay, what are data structures? It's very easy to understand that. Now, advantages of data structures. What is the use? Advantage of data efficiency and reusability, abstraction. Efficiency is what? So let us discuss what are the advantages of data structures. One is this efficiency. Once data is structured in any data structure, once data is stored, so once it is organized in a memory location, so efficiency is very fast because of in terms of time and space complexity. Okay, once data is organized, otherwise once data is stored in a proper manner, so it can be accessed. Its efficiency means accessing is very fast in time and space complexity. Time means what? Time complexity means so how much of time an algorithm will take to execute that code, means how much of time an algorithm means whenever algorithm is being converted into code, so how much of time that will be taken to complete that, to execute that code, how much of time. So if less time it is taking, we can simply say that its efficiency is very fast. And space complexity, in terms of space complexity, if we have written lengthy code, so ultimately it will take more space, more memory. Understood? If more memory is there and more code we have stored, so it will take automatically more time. These are two terms whenever we will deal with the data structure: time complexity and space complexity. Time is nothing but if we have written small code and its execution time is very little bit, so that is called complexity is small complexity, otherwise easy complexity. And space means if we have written more code, it will take more, consume more memory, ultimately it will take more time. Okay, so if we arrange the data in proper manner, the efficiency, okay, that is data structure. Okay, next is what? Reusability. So once the data is structured properly, so it can be reused many times. Okay, next is abstraction. Abstraction means what? The core function part that can't be shown to the client, that will be hidden. So the client can see only the interface section. So user interface will be shown to the client, and behind of that, whatever the main core part, that will not be internal working of the code, that will not be shown. That will be abstraction. That is called abstraction. Abstraction means the code will be, the main code, functional code will be kept as hidden. Only that interface, user interface, interactive, whatever the code that will be interacted with the client, that will be shown only. So these are three main. If we structure the data, if we arrange the data proper in computer's memory, so efficiency in the terms of time and space complexity, that efficiency is well, and code can be reused again. So the main functional part of the code can't be shown to, that will be hidden to the clients. Okay, so now I have briefed that how many types of data structure